Good day to all learners and especially the chemical engineering students. In today's class, in this YouTube e-learning series, we'll start with the introduction to reactors. In this class, we'll discuss some basic terminology and basic reactor engineering aspects, some typical applications of reactors, the main types of the reactors used in the industry, and we'll also see the basic design principles for the reactors. At the end, I'll show you one very short quiz that you can check your understanding and knowledge from today's session. Let's get started with the reactor. So the definition of the reactor and its typical applications. First of all, the reactors, they are such a vessel or just a stage which makes two or more substances react chemically with each other and form one or more new components. So if I give you one example like this, so as you have already learned, A plus B, it could give you C. This is, as you can see, A and B. We have two substances and they will give you just C, or sometimes in some reactions you get additional D2. It means you need two reactants, A and B, more than one, and as a product you can get more than one new components. Okay? And this reaction is occurred in general in the reactors. And the reactors or reaction kinetics is one of the most common subjects that's taught during the university classes. Let's see what are the typical applications. The number one application, it's in the petrochemical industry. Because in petrochemical industry, the reactors, they are used to break down some hydrocarbons, then also support polymerization reactions for plastics and the rubber applications. The main aim here is to be an integral part of the across the industries and enhance the production and also increase the efficiency. Okay? The second most common one is the pharmaceutical industry. Actually, the reactors are, I would say, the heart of the pharmaceutical industry because most of the typical applications, most of the typical reactions, they are done in the batch or sometimes in the CSTR reactors as well in the pharmaceutical industry. They are synthesizing active ingredients and produce biologics, so whatever we need to get from the reactors as a product. I have added one more application, which is the nuclear one. By the way, you can see the typical pictures, how the reactors look like during the construction phase. This is one of the typical images. In the next lesson, I'll show you some important reactor images as well. The last one I have added for today, it's the nuclear industry. In the nuclear industry, I believe most of you have already seen this kind of the process diagram. As you can see, the main, again, heart of the process, it's again the reactors. So whatever we get from this reactor, it is mainly used and turned into the different type of the electricity, the different types of energy to provide the electricity to homes or to different factories and etc. So if I summarize from this slide, we learned about the reactor definition, how we understand the reactors. Then we learned about there are mainly, let's say, typical three applications. The first one is the petrochemicals, then pharmaceuticals, and lastly is the nuclear industry. So it's how it look like the reactor in the nuclear industry that you can see from this diagram. Let's go to the common ideal reactor types. Why I have mentioned the ideal reactor types? Because in general, the reactors are not only the ideal, so they could be also the real or non-ideal reactors, and it comes from actually the differences in the heat balances, heat transfer, sometimes non-isothermal operations, and especially the mixing. Okay, this is the subject for the another video. I'll not discuss it here. Here I'll only discuss the ideal reactor types. Okay. The ideal reactor types, we have the three of them, which are mainly commonly given out in the industry. The first one is the batch reactors. You can see BR simply, continuous stirred tank reactors, CSTR, and the last one is the ideal one is the plug flow reactors, PFR. So from these pictures, this one here, it's the PFR. It looks like a vessel or just horizontal separator. This is PFR. Then we have CSTR. So you can see the CSTR and recognize it from its motor agitator, as you can see it here. And we have the BR batch reactors, and it's here in the pharmaceutical industry, in food industry. It is also very commonly used, and especially in let's say that if you have the plant and they have the typically lab scale operations, they are also using sometimes the batch reactors as well. Okay, and from this slide we have discussed the three main common ideal reactor types. Now let's go to the basic elements for reactor design. So the main aim when we are designing the reactor is to find finally the reactor volume. Okay, the reactor volume, it's our main aim. So to know and to get to find like the reactor volume, you need to know the three main elements. The first one is the knowledge of nature of reaction. Second one is selection of operating conditions, and the third one is selection of reactor type for a given application. Let's start with the first part, main element or section, let's say. Knowledge of nature of the reaction. That's the typical reaction that I had given you in our first slide. A plus B, it will give you C plus D. So here you need to know first of all what are your typical reactants for the process. A and B here is your reactant. C and D, it is your products. Okay, you need to first of all identify what are your reactants and what are your products. Secondly, you need to know your stoichiometry because your stoichiometry will help you identify your reaction rates at the end or during design phase, and also to determine with the help of stoichiometry, you will know that nature of the reaction. Okay, this is typically like this. Then the last one here, it's the type of reaction. It could be catalytic or non-catalytic reaction, homogeneous or non-homogeneous or heterogeneous, let's say, or reversible or irreversible. Because in the petrochemical industry, some of the reactions could be only irreversible, or some of the reactions, depending on the operating conditions, they could be reversible as well. And during the lab scale, let's say the applications, we need to take into account this process, and we need to design and select our operating conditions based on this type of the reaction. Okay, the first element, it's already completed. Nature of the reaction. Let's say we have already got some information about nature of reaction, then we move to operating conditions. So you need to know pressure, temperature, and concentration of each reactant, and at the end you'll find your products as per calculations. Then you need to know your flow rates. Again, in the typical lab scale, it is very small flow rates, but when you, let's say, apply to the plant-based calculations, you are scaling up your results. Lastly, you need to know your catalyst. Just for your information, the catalyst is not depending on, let's say, your stoichiometry. Actually, it depends on which type of the technology are you working on it and which type of the reactor too. So will you work on it? So it doesn't matter like your flow rate, your sometimes even the stoichiometry or product reactants, but it mainly will result into your, let's say, efficiency and effectiveness, or at the end the conversion, and it will help you to find out the concentration as well with the help of right catalyst. Okay, the second element is also completed. The third one is the selection of reactor type. So we'll discuss it in the next class. So when to use the batch reactor, when to use CSTR or PFR, but the selection of these reactors will help you identify the right reactor volume. In case of, let's say, you have chosen the wrong application, for example, liquid, you have chosen, for example, just for random example, I would say the PFR. So it could result in wrong volume estimation. So that's why you need to be very careful for selection of the reactor. The three elements, if they are all of them ready, you go for the reactor volume calculation. And actually your reactor volume calculations, they are dictated by, in general, how large the reactor volume it will be. So it will help you to identify this at the end. Okay, so estimation of reactor volume required to process given amount, like we can see moles or molar rate of raw material to desired amount of products. So you will identify your reaction rates and at the end your reactor volume. I hope it is clear now. So now we'll move to the quiz. We have completed the main part for this presentation. I'll discuss with you what I'm gonna discuss with you in the next class, in the next session. But before that, let's check our knowledge. At this stage, you can stop the video for 10 to 15 seconds. Then you can check your answers with mine in the next slide. Okay, the first question is, tell us which of them is the right reactor definition. So it says the reactor is a vessel which makes one or more substance react chemically with each other and form one or more new components. And this one, the only difference is the two or more substance. Here is the one or more substance. So as we discussed, you need at least two substance, because just one component, they cannot be reacted with anything. They should be A plus B at least, that you will get C or C plus D. Okay, so that's why the right reactor definition, it will be the answer B. One of them is not the reactor type, CSTR, PFR, and TR. We know CSTR is continuous storage tank, PFR is plug flow, TR, we don't know what is TR. It should be BR, batch reactor, so that's why the right answer, it will be TR. Knowledge of stoichiometry is important to define the followings. Okay, we discussed this as well. Stoichiometry, it's important to define not operating conditions. Reactor volume, yes, because you need to find out your reaction rates. Also reaction kinetics, that's right, because reaction rates, kinetics, they will be defined together. And catalyst, no, it's not dictated anything for the catalyst. The right answer, it will be second and the third option. Last question is true or false. At the end of reactor design, we need to provide reactor volume. Yes, that's totally true. And we said that your reactor volume, it will be dictated by your reaction kinetics or reaction rates. So here's the answers. So if you are interested, it's the same B, TR. We don't have this kind of reactor volume, reaction kinetics, and it's true. That's all for today's class, and in the next video I'm gonna share with you some applications of each type of the reactor. Then I'll get some introduction for residence time distribution and also reaction rate concept. Thank you very much for watching out this video. I hope you enjoyed and you learned something new from today's session. Thank you, and if you have any suggestions, you can reach out to us, especially with the Gmail or WhatsApp or Instagram. Thank you, have a nice day.